I'll try to fly a little bit through here. As I said this morning, I had a bunch of coffee. I've had some more since then. So I'm going to try to buy some time back here. What is LExSO? LExSO is viewed as the what's next after LRO. Let me be very clear for a second. Ryan alluded to Monty Python. LRO is not dead yet. We're not going anywhere. We're still there, still a happy, functioning, healthy mission. Looking forward to many, many more years of operations, but it's time to start thinking about what does come next. LExSO is not the LRO follow-on. It is not. It is the next in a progression of orbital missions. We're going to talk a little bit more about what that looks like today. We have put together a preliminary science team inside NASA Goddard to help identify what should this next level mission look like. See David Hollabaugh-Baker, Casey Hannibal here. They are going to be able to speak to LExSO. If I have to leave a little early before the question and answer ends, because I got to go pick up a kid from camp and the rate starts at $20 a minute, you're late. So I'm going to just try to get through this. I'm happy to serve as the project scientist of LExSO. We've got a great internal science team to put together to define what could this mission look like. Let me be very clear to many of the people who don't know what a pre-phase A mission is, and I still have to remind myself what that is. A pre-phase A mission is really defining what could a mission look like. We work with engineers. Charles Baker will talk after me and clean up the mess that I leave here on the stage about, what does it mean to build a spacecraft that can, but does not have to last long? And there's an important distinction. LRO has lasted now over 14 years. It was built to last 2 or 3. And that's not to say we over-designed LRO. We designed an incredible spacecraft. Charles can take a lot of credit for that. When we look at LExSO and what follows next, we have to build a nimble, agile spacecraft that can last a long time, but should last at least 2 to 3 years. In defining this mission, we have looked at inputs from the exploration side of the house. What do they need as Artemis matures, as future missions to the lunar surface evolve and have additional requirements? We've looked at results from RISE 2. So direct relevance from survey to feed into designing our mission here. And of course, one of the most important documents to come out recently is the ClockSat report to tell us what are some of those capabilities that we need from future orbital missions. We know that the community is interested in this, and we know that there will be a competition to put together the science team, the instrument suite. This is not about us trying to keep ourselves busy. This is about us getting something ready to suit the needs of the community long term. So pre-phase A, it's a concept study. We're looking at what should the mission look like? What are a possible suite of instruments? What are the requirements for orbits? LRO has defined a lot of trade spaces that benefit the community. LRO going into this quasi-stable low fuel orbit has enabled this decades-long mission. How can we leverage that going forward? And what are the needs of science communities? Again, ClockSat helps us define that. And what are the needs of the exploration community as we look forward to a long duration surface missions, both crewed and robotic? And I can't state this highly enough. ClockSat is the basis. We build off of that amazing work. Okay, to summarize the ClockSat report, and I know that we'll hear more about that over the next weeks, months, and years, we know that we need to have a continuous capability in lunar orbit. We know that we need to have time and, finding two, yes, we loudly agree that it is long overdue to start looking at what should come next for long duration lunar orbiting missions. That one single spacecraft will not answer all of the needs. And we have defined that and redefined that time and time again in LExSO. Every time we look at a potential instrument, we say, is an LRO-like spacecraft, is an LRO-like orbit optimal for that measurement, yes or no? And in a number of cases we've said no, which I think begs the question for future other orbital missions. We know that there's going to have to be a number of different scales that instruments measure. I don't know that we'll need to image the entire moon or map the entire moon at certain scales topographically, but certainly at higher spatial resolution, we know that there are going to be a demand for those high resolution data sets. We know that we do need global data in certain cases. We do know that we need long baseline measurements. LRO has told us how the moon changes over 14 years. And come and ask me next year, and 2 years, and 3 years, maybe we'll be talking about what the moon changes like over 20 years. We know that there's needs for new types of measurement. We know that there's going to be a huge volume of data coming down. All of these things drive us towards the design of one or more missions to the surface of the moon. Let me talk a bit about direct results from survey that feed into this. Sherry Eccles has helped put this together to tell us exactly how field operations operating on the surface of a planet, either on the Earth or eventually on the moon, leads to the need for high resolution data sets, that we need to get slope maps and topography in certain areas at less than or equal to 1 meter baselines. And with that data set, what you can do more in terms of planning and operational parameters on the surface of another object. And certainly being able to identify hazards at the sub-meter scale, particularly in the polar environment, is going to be critical for long duration Artemis missions. Here we are. The star is roughly where we are. We have LRO's ESM-5. When I showed this slide before, there was a question after LRO ESM-6. I have no question that we can have the capability, the fuel on board LRO to see a 3-year ESM-6 that might take us to the end of 2028. Now, of course, tomorrow, something might happen in the spacecraft. We are always playing with the devil with LRO, that tomorrow, the next day, the next week, something may happen. But by God, the engineers have built us an incredible spacecraft. And so as long as I don't screw anything up, ESM-6 will be a reality. Sometime LExSO comes in, and I want there to be a handshake. I want there to be an orbital handshake of data, of observations, coincident observations in lunar orbit. Now, what I want doesn't matter. If I wanted, I mean, I'd have, flying cars and teleportation by this point if everything I wanted. Actually, I'd want like 8 hours of sleep. That's all I really need. Just give me 8 hours of sleep and an infinite supply of coffee, and I'd be so sad. Let me just wrap up here. So, ClockSat very clearly did not prioritize the science that's to be done. There's a whole host of science that could be done in future orbital missions. We went back to them and said, yeah, but we really could use, what are your must-haves? They came back to us with a list, and not in priority order, but these are the things that we think are very, very important. Higher spatial resolution imaging, volatile composition, surface composition, geomorphology, thermophysical, and exosphere studies. Fantastic. That gives us a place to start to define an instrument suite. We went to the exploration community. What do you need for ISRU utilization? We just heard about Viper and the things that they are going to do. The connection between orbital data and surface measurements is going to be critical, but we want to have the orbital data that can drive. Go to this place and set your well here to harvest that lunar volatiles. One mission alone may not address all of those high priority things, but we can try with LExSO. So at a very preliminary stage, we have an initial set of candidate instruments that we will recommend to headquarters. Headquarters can put together a solicitation of instruments. We can add or subtract instruments. We also note that coming very soon, Trailblazer will get to the moon. Now, Trailblazer will make compositional measurements. They will determine orbital volatiles, but they may not get the data set that we all think we want. They will give us that tantalizing taste of what's left to come. And so while we don't want to be redundant with, we want to complement and build on the results that are going to come not only from MCube, from LRO and Trailblazer, but really set the stage for future operations. We're looking at aspects of mission design, including potential instrument options. And again, we're going to make a recommendation to headquarters that here's a mission that could work, that can close, and leave it to them to decide what to do next. I'll leave with this kind of some future thoughts. We have changed our understanding of the moon 15 years ago at NLSI and eventually going into Survey. We have seen in this community the dramatic change in our understanding of the moon thanks to LRO's data, and LExSO will build upon that so that all of the early career folks in 10, 15, 20 years from now can get up and talk about not just the amazing things that LRO has done, but the amazing things that LExSO is doing at the moon. With that, I'll conclude. Thank you.